Okay, this video is going to review how to solve two-step equations, or basically those questions that are asking you to solve for x, what's the value of x, this might be like a y, what is the value of y, what's the value of w, where you're just trying to solve. So when we introduced this, we talked about modeling that equation. So let's say that I have, and I'll write this in green so you can see it, 3x plus 2 equals 11. Okay? So we said, well, if things equal each other, I don't know what x is, right? But I know 3 times whatever it is plus 2. This needs to equal 11, and this equals 11, so that these kind of balance out. So we kind of talked about this balance beam. Let me write that a little darker. Or like a scale. Okay, if you think of if a scale is equal, right, it's going to look like this. If one side is greater than the other, then it won't be a balanced scale. Okay, so we started with modeling it. And on this side, you can see that I have 3 x's. So I'm just going to write those 3 x's right here. And then we said plus 2, or 2 positives. So I have 2 little positives on this side as well. I'm sorry those are white. That's kind of hard to see. Okay, then on the other side, I have 11. And they're positives, not negatives, right? So I have 11 positives. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And right now, I can see that these are balanced, right? I don't know what x is, but it's looking like x is a bigger number, right, to keep this balanced. Okay? My goal is to figure out what this x is. Just one of these x's. I know there's 3 of them, but I want to figure out what just one of them are. Okay? So how we kind of say it is we want to isolate it. We want to get x all by itself so that I can say x equals whatever it is. So right now, x is hanging out with 2 other x's and 2 positives. So we're going to get rid of these guys first. Think of it as backwards order of operations. This is your little plus 2. That's a pretty weak operation, right? Adding 2 is not as strong as like multiplying by 2. So adding 2, we're going to get rid of plus 2. Well, how do I get rid of 2 positives? I can't just take them away, right? Because then it won't be balanced. So I have 2 positives. To cancel those out, I'm going to use 2 negatives. And those make a 0 pair, right? Think of like in science. You have an electron and a proton. Those are going to cancel each other out. So those 0 out. Okay? But if I added 2 negatives to this, to the left, I have to add 2 negatives to the right. Otherwise, this won't be balanced. So I'm going to add 2 negatives to the right side of my balance. Okay? These are going to cancel each other out. So those go away. Goodbye. Goodbye. These cancel each other out as well. Goodbye. Goodbye. And I'm going to be left with, let's see, 1, 2, 3, 4, 6, 7, 8, 9 positives on this side and 3 x's over here. Okay? So now over here, if I have 3 x's all together, those are going to equal 9 positives. Okay? If I divide these 3 x's by 3, so I take those 3 x's and I put them in 3 separate groups, right? I'm going to end up with 1x. So if I divided this into 3 equal groups, I need to divide all these into 3 equal groups. So I'm going to do that. 1, 2, 3, 2, 2, 2. And I end up in each group. So if here's my groups, right? I'm going to end up in each group with 3 positives. So I can see that x equals 3. Okay? So we started out with modeling it. Some of us might have needed the models for a while. Think of the modeling as almost like training wheels, right? You don't want to be modeling for the rest of your math career because these numbers get ugly. They turn into decimals, and it's really hard to model with a decimal. I have to like cut these little counters in half. So what we're going to do is we're going to look at it algebraically. The same equation, which we know x should have equaled 3. So I have 3x plus 2 equals 11. Let's talk about what we just did. We got rid of those 2 positives with 2 negatives. Well, the opposite of adding 2 is subtracting 2, so those go away. I'm going to subtract 2 from both sides. I end up with 3x equals 9. Okay? Then I need to find 3, so I'm going to divide both sides by 3. And I'm going to get x equals So 9 divided by 3 is 3. Okay, and that gives me my answer. Okay, these just take practice for you to get really comfortable with. I'll give you another example, and I would encourage you to pause the video and see if you can do this one on your own. Okay, 5x minus 2 equals 17. Remember, my goal is to get x by itself. Right now, x is multiplying by 5, and we are also subtracting 2. So think of your order of operations, right? Adding and subtracting was the last thing you did. So if I'm working backwards to get to x, I'm going to get rid of this subtracting 2 first. So the opposite of minus 2 is plus 2. Or you can think of it as positives and negatives. The opposite of negative 2 is positive 2, so those will zero out. Remember that balance beam, or that balance. If I added 2 to the left of the equal, I have to add 2 to the right of the equal sign. So 17 plus 2 is 19. Here's my equal sign. And over here, these went away, but I'm left with 5x. Is x by itself? No. Right now, it's being multiplied by 5. The opposite of multiplying by 5 is dividing by 5. Think about it, like 5/5 will give you 1, right? So you're left with just 1x. So the opposite of multiplying by 5 is dividing by 5, so those will essentially cancel each other out. If I divide the left by 5, I have to divide the right by 5. And I'm going to get x equals, and I would have to do 19 divided by 5, or I can leave that as an improper fraction, which for this video I'm just going to do just for time's sake. So x equals 19/5. Okay? The only other kind of question that you might see, or situation, is where you have x's on both sides of that equal sign. So think about it as like, we explained it in class, if you have like a bunch of cows in a field, right, and you just want one cow. So let's say the x's are our cows. And here's like a gate, okay? I have 3 cows over here, and I have 5 cows over here. I just want one cow, okay? First thing that a rancher is probably going to do is try to get all the cows into one section, kind of group them together from that field, and then they're going to try to single out just one of those x's or one of those cows. So first thing I want to do is either get all my x's on this side or all my x's on this side. Okay? Right now, and I'm just going to think this through logically, I have more x's over here. There's 5 of them. So I'm going to move these over here. Okay? So here I have 3 x's. I'm going to subtract those away from this side. So I'm going to get rid of that. So minus 3x. Those go away. And if I subtract 3x from this side, I have to subtract 3x from the other side. So I'm going to get 2 equals 5x's minus 3x's will leave me with 2x's. And I still have that little minus 1. And now it looks a lot more familiar to me. Okay? So I want to get x by itself. It's not a big deal that x is on the right side. Not a big deal. I want to get it by itself. Right now it's being multiplied by 2, and I'm subtracting 1. Okay? So, which is a weaker operation? Well, subtracting 1. Right? Adding and subtracting is a weaker operation. So, I'm going to get rid of that first. The opposite of minus 1 is adding 1. If I add 1 to the right, I add 1 to the left, I end up with 2 plus 1, which is 3, equals, and all that's over here is 2x. I'm not done yet. X is not isolated. Right now, x is being multiplied by 2. The opposite of that is dividing by 2. So if I divide both sides by 2, I get, and I could do 3 divided by 2. This is 1.5. I'm just going to leave it in proper 3/2. Okay? So that's a main concept. One little kind of note I want to make. If I have 1/4 x, which you can see, right? If I have 1/4 x equals, let's just say 8. I'm almost there, okay? Right now, x is being multiplied by 1/4. The opposite of that would be to divide by 1/4. So you have a couple of options here, and I'm going to show you. You're doing the same thing, but one of these is probably going to make more sense to you. I don't care which one. But I'm going to solve this 2 different ways. Okay. Right now, x is being multiplied by 1/4. The opposite of that would be to divide by 1/4. And I know these fractions look weird, but we know they cancel each other out. If I divide the left by 1/4, I divide the right by 1/4. Okay? So basically, I end up with 8 divided by 1/4. So if you haven't watched the fraction operation video, I would do that. But I have 8 divided by 1/4. I'm going to CSI, KFC, whatever you want to think about. The first fraction stays there. The division changes to multiplication. And the second fraction inverts. So I end up with 8 times 4. And I can get my answer there, okay? The other way that you would do it, so if this makes sense to you, man, use it. The other way that you could do it, though, is basically, if I can make this guy turn into one whole number, right? If I can make it turn into one whole number, then I just end up with 1x, okay? So how am I going to make this one whole number? If I multiply it by the reciprocal, which is basically what you did here. Okay, I have 1 over 4. If I multiply this, so 4 times 1 is 4. 1 times 4 is 4. I'm going to end up with 4/4 x. What does 4/4 really mean? 1 whole. Okay? And if I multiply the left by 4 over 1, I need to multiply the right by 4 over 1. And look at that. You end up with the same question. Okay? I will tell you, some of our brains love this. This makes sense to us. Some of us are going to like this more. It doesn't matter which one you feel comfortable with. You just need to understand, don't freak out when you see a fraction as a coefficient. Okay? It's the same concept. You need to cancel out somehow, whether by dividing by 1/4 or whether by multiplying by 4 over 1, which is the reciprocal, when you're dividing it, and make this 1 so that you're left with just 1x. Okay? So that concludes our video on solving for x, or those two-step equations.